Today's lesson is on graphing the square root function, and this is kind of part A. There will be a part B. Here's just a general form of that square root function. Just kind of an interesting thing. So quadratics, which are x squared, make parabolas. And then square root, which is the inverse, it kind of makes it's like a sideways parabola, but it cuts off the bottom. It's just the top half, which we'll talk about why later. We're going to start by graphing the parent function. A parent function just means the most basic form of a certain type of function. So f of x equals square root of x, or, y equals the square root of x. So if we make a function table, we'll pick values for x, input and get values for y. We'll plug them into the function square root of x. So let's think about what values we'll pick for x. So let's see, we don't want to pick negative numbers because those would give us an imaginary number. Can we pick 0? Now, what numbers can we pick to avoid decimals? You can graph decimals, but let's try to avoid them. Well, we could do 1 and 4 and 9 are perfect squares. So the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, and the square root of 9 is 3. So let's just plot those points. 0, 0, 1, 1, 4, 2, and 9, 3. So right there. And the y values will keep, x values and y values will keep increasing. But we're never going to have less than 0 or less than 0 this way. So that leads into our domain and range. So domain represents all the x values of a function. Well, it's going to hit all x values. They can get larger and larger and larger, but they just can't be negative. So all x values that are greater than or equal to 0. The same thing will be true for y. So range is y. Range is y. And same thing, they will keep going up and up. As x goes up, y will go up. Y is greater than or equal to 0. And the function would be undefined when x is less than 0. So for negative numbers, it is undefined. And then end behavior is just describing what happens at the ends of the graph. Well, the one end, as x approaches 0, y also approaches 0. And then the other way, as x approaches positive infinity, y also approaches positive infinity. Now we're going to look at graphs that translate or move the parent function. And for this one, we'll look at horizontal translation. So horizontal meaning left and right. So first, I'm going to just regraph the parent function. These ones you should just kind of have memorized. The points 0, 0, 1, 1, 4, 2, 9, 3. Graph the parent function. And then we're translating it. So we're going to put both of these functions on this graph. This first one, notice how the plus 8 and the minus 4 are underneath the square root. So when you add or subtract underneath the square root, that's what moves it right and left. Now, it's kind of opposite of what you would think. A plus 8 underneath means we're going to move left 8. So what you can do is take each of your parent function points and just move them left 8. So I'm going to just count, let's see, 0, 0 becomes negative 8, 0. 1, 1 becomes negative 7, 1. 4, 2, let's count 1, 2, 3, 4, 5, 6, 7, 8 becomes negative 4, 2. And then 9, 1, 2, 3, 4, 5, 6, 7, 8. So we can draw the translation of it. And now let's think about domain and range of the blue function. So the x values, let's see, we can't go left of negative 8, but we can be exactly negative 8. So it's all x values that are greater than or equal to negative 8. And then the range, well, the range, we're still on this axis and still going up. So y is still greater than or equal to 0. So now let's look at the other way. So when you are subtracting 4 underneath the square root, we will translate to the right. So you always start with the parent function. So moving these points, right 4. So 1, 2, 3, 4. And the last point, it'll move off of the graph, so we can just graph that. So now the domain and range of the red graph, well, it's moving to the right. The smallest point is the 4, so all x values greater than or equal to 4, and the range is the same. Y is greater than or equal to 0. All right, so now we'll be translating the parent function vertically. Vertical translation, I guess I should draw the line this way, means up and down. So first always start by just graphing the parent function. 0, 0, 1, 1, 4, 2, 9, 3. All right, so now notice how these functions look different than the last ones. This time we are adding or subtracting numbers that are outside of the square root. They're not underneath the square root. So that's what causes the vertical translation. So now when you are adding 3 outside of the square root, it's exactly what you would think. It moves it up. So we're going to take all of the points of the parent function and just move them up 3. 1, 2, 3. 1, 2, 3. And there we go. So the domain, so those are the x values. Notice how when you do a vertical translation, the x values stay the same. It's all x values greater than or equal to 0. But the y values change. We've moved them. So the smallest y value is 3. So y must be greater than or equal to 3. All right, so now minus 6, you can guess, this will move the function down. So starting at the parent function, move each of the points down 6. And there we have it. And notice once again, the domain is still x is greater than or equal to 0, but the smallest y value is negative 6. All y values greater than or equal to negative 6. All right, and for our final graph, there'll be a combination of both horizontal and vertical translations. So once again, let's just graph the parent function. 0, 0, 1, 1, 4, 2, 9, 3. All right, so let's think here. The minus 2 underneath the square root is always opposite of what you think. Minus, you think left, it's the opposite, you're moving right. But the plus 3 outside of the square root is what you would think. That's our vertical translation. We're moving up, right, and up. All right, so right 2, up 3. So starting with 0, 0, right 2, up 3. And then with 1, 1, right 2, up 3. With 4, 2, right 2, up 3. The last one will go off the graph a little bit, but we can still get it. Right 2, up 1, 2, 3. So there we have moved both a horizontal translation and vertical. So now let's think about that smallest point. The domain, it would be this way, is greater than or equal to 2. X is greater than or equal to 2. And then the y value, it's going to be greater than or equal to 3. So there you have it, the introduction of graphing square root functions. Good luck.